on to proportional relationships, and that's a huge 7th grade standards, knowing proportion. So knowing proportion, we want to be able to identify what is a proportional relationship. Some of you might be thinking proportions, set up a cross product or set up a proportion equation. It's not that way with graphs. It's a little bit different, but it's a pretty, once you are instructed, it is a pretty decent concept. So, your learning target, you're going to be able to identify proportion relationships and determine what's called a constant of variation. When I say proportional, what I mean is y is varying directly with x. They're proportionate, okay? Y varies directly with x, means it's proportionate. What that means, if you say y varies directly with x, all you do is multiply x by something to get to my y. That something happens to be our constant of variation. That something we call k. Please know that y equals kx is the exact same thing as what you've been instructed so far. It's the same as saying y equals mx. K is a slope. It's a constant of variation. When you think of a line, you think that it is constantly changing at the same rate. Okay? Same thing here. So this k is really my slope. This k is my slope. Some students are like, why do we call it k? You just taught us m. It's just like the multiple ways we can be known as. I could be known as Miss Mahold, Angie, Angela, yeah, so Mahold, some kids just call me Mahold, Miss M. I have so many different names. It's the same thing with slope intercept. Okay, the math master.
What's your real name?
So I could be going. Okay, let's stay on track here. That K and M are just different ways to represent slope. So Kx is the same thing as Mx. It's just a different representation. What it is, this K is also the constant of variation. Because slope is how your graph is constantly varying, constantly changing. It's what we multiply x by to get to y. And kind of a repeat of a fact I gave ahead. But the constant of variation is just the slope. And the slope is what we multiply x by to get to y. Here are some properties. Y is strictly dependent on x. That's what I've said before. Here's the biggie. There is only x and y involved in the equation. Y equals kx. Something times x. I do not have a plus or minus something. I actually have a plus 0. If I were to graph this, my y-intercept would be 0. Which brings me to the next fact, that it will always, this is the big 7th grade standard, it will always go through the origin on a graph. Because I don't add or subtract anything to the x to get to the y. Okay? All right. That's your main learning target today. You're going to have to be able to identify if an equation represents direct variation. There's one more thing that I didn't include on your notes that you need to write down. And I want you to make a heading identifying constant of variation, which is the slope.
On the front?
Yep, on the bottom. So you're identifying constant of variation from a graph. Now I'm going to help you think this through. Most of your graphs today, or from your assignment, it's going to want a unit rate. a unit rate, you will always want a 1 on the bottom, or get a 1 on the bottom. That's where you might want to create a proportion. For example, let's say I have this proportional relationship. So I know I go through. So I know I go through the origin. And then let's say that I go through this one. Okay? So it's going to say, what is my constant of variation? Or how much for 1? Well, I find my slope. Constant of variation is just slope. So I find my slope, rise over run, and then I want to know how much for 1. So it looks like I went up 2 over 3. So my slope is 2/3, right? But then they're going to say how much for 1. Anytime it says how much per week, per shirt, per any, the term per means unit rate. So you want to know how much for 1. And this happens to be like 0.6 repeating. Okay? So you're going to solve this in that situation. Okay? All right? So that's going to be, I think that's R1 where you identify, or R2 where you're going to identify the constant of variation. You figure out the slope and make sure it has 1 on the denominator. If it doesn't, you make it. Okay. Woo. Next one. It's kind of, I slightly cheated here, but again, it all represents having y equals kx, being able to only have the x term and the y term. Does this only have the x and the y term? Yes, my y-intercept would be 0, so this would be a direct variation. 4y minus 3 equals 8x would not be direct because it has that 3. I want only x and y involved. Not direct because it has that -1. This is direct because the 0 can disappear. So that would be a proportional. By direct, I mean proportional. Okay? Proportional and not proportional. Direct is just the terminology for 8th grade. Proportional is 7th grade terminology. Whoa. Is there only x and y here? No, this would not be direct, proportional. Is there only x and y here? Yes, proportional. Okay? All right, translating into y equals kx form. That just means get y alone, and we have done that. Because direct variation, proportional relationships is all related to slope-intercept. So we want to make sure y is on the left. We want to make sure the x term is on the right. And then to get y by itself, you always, in the last step, divide through by what is in front of y. So here I would divide through by 2 because my y is on the left and my x is on the right. I can just do the division. Y equals 3/2 x. This is my constant of variation, slope. Slope is constant of variation. Get my y to the left by just flip-flopping. Divide through by what's in front of y, so I'm going to divide by 4. Y equals 2x. My constant of variation is 2, which just means my slope. Get my x to the right-hand side by minusing 5x. 2y equals -5x. Make that 0 disappear. Divide through by what's in front of y. Done. Okay, direct variation, again, key word, goes through the origin. Origin means 0, 0. So, is this proportional? No, it's not. It does not go through the origin. Is this line proportional?
Yes.
Yes, because it goes through the origin. Just identifying. When your R1 is just saying yes or no, that's awesome. Is this one proportionate? No, it does not go through the origin. Is this one proportionate? Yes, it goes through the origin. Last concept, bumping up the rigor slightly. We're going to find constant of variation given a point. So the first thing you're going to want to do is identify the x and the y. Now you did this a lot recently where you did a lot of substituting, so you are pros at this now. Then we're going to substitute the x and y value into this format. It's the same thing as mx. It's just we use k when it's only proportional. This should be get k alone, because that's your constant of variation or your slope. And then make sure it is in slope-intercept form. Y equals mx or y equals kx. Okay, so I identify my points. I write what it should look like since it's a proportional relationship. I know it's going to look like y equals kx. I'm not going to have a b involved. I substitute. 7 goes to the y. 4 goes to the x. I don't have my k or my m, so I'm going to solve for it. 7 equals 4k. Divide through by the 4. 7 fourths equals my k. Now I get into y equals kx format. Y is equal to my constant of variation, which is my slope, 7 fourths x. Done. Now I could graph it. It goes to the point 0, 0, up 7 over 4. Up 7 over 4. Y equals kx. Because I know I'm assuming that they tell me this is the proportional relationship. So if it's a proportional relationship, you do this. You can't do it if it's not proportional because you have to have a y-intercept involved. Substitute what you can. 12 equals 5k. 12 fifths equals k. I got that by dividing through by 5 to get my k alone. Y equals 12 fifths x. Last one. Put the 6 with the y, the 10 with the x. 6 equals 10k. Divide through by 10. 6 tenths equals k. I can simplify that. So I'm going to turn that into 3 fifths. Y equals 3 fifths x. And that is your lesson for today.